Now let's see this issue here. What is the angular velocity of a straight line joining the two particles of rigid body executing combined motion in a plane? So we experimented with knowing the velocity vectors. Now here you can see the orientation changing here. Okay, with respect to any chosen reference line. See, we experimented there with respect to what? Point. Now we are choosing a reference line. I suppose you are able to differentiate between the line and a point here.
Yes, sir.
Okay. So, so what have we got to say here now? So this line A dash B dash and line AB. So this body at time t1 it was with this orientation. At time t2 it is with this orientation. And obviously, I think all of you are smart enough to say that this body's orientation has changed, therefore it has rotated, and it has also translated. Yes. Okay, so therefore it's a combined motion, and here at this time it is θ1, this is θ2. Okay, fine. Now, what is the angular velocity of a straight line joining two particles? That is, what is the angular velocity of this line? Right? Of the two particles executing the combined. Right? Okay. So, what have we got to say? What is the angular velocity of this?
θ2 minus θ1.
θ2 minus θ1 divided by t2 minus t3.
Yes.
Okay.
Yes.
Huh?
Yes.
All of you are around study. It is not difficult at all. So, therefore, omega AB is equal to d theta by dt. It is so. Okay. I made the diagrams and all ready so that we can quickly learn, because we can save the time. Now, is there angular velocity equal? Is this angular velocity equal to angular velocity of B with respect to A, or with respect to A, or the angular velocity of A with respect to B? That is this right? Omega A with respect to B is equal to omega B with respect to A, and this is equal to omega of the omega AB means what? The line itself.
Yes, sir. Yes.
I suppose you understood that. This line itself is AB. So, is this all equal? You have to prove. Yes, we know it is equal. And the question is, can you prove this?
Yes, sir.
Can you prove, all of you?
Yes, sir.
You should be able to.
Yes.
You should be able to prove. You want to prove? Okay, I'll give you 2 minutes time, quickly. You have to cover a lot of ground. So therefore, I'm slightly hurrying it up. I like your attitude. You said, yes, sir, we want to try. That's good. So, omega of A with respect to B and omega of B with respect to A must be equal to omega AB, the line itself.
Yes, sir.
So, did you do that? What did you do?
Sir, I took the line parallel to the reference line and passing through A, sir. For both cases.
Reference line passing through A, you took a line
parallel to the reference line.
Parallel to the reference line passing through A. Okay.
So first it will substitute θ1. Second, at time t2 it will substitute θ2. So it is changed like.
That means you have drawn a line passing through, say, A dash or A,
yes, sir,
parallel to B, and then what did you do?
Again, another line parallel to A, sir.
Another line parallel to A. Parallel to A means what?
I mean, passing through A and parallel to reference line.
That is one line that you are drawn like this.
Another line with A dash.
Another line with A dash. Then
angles which it will make be that line with respect to reference line from at A said theta 1 to theta 2 it has changed.
But theta 1 is this side, theta 2 is that side. How did you relate?
The reference line will be same as well.
I doubt. Anyway, you are coming closer. Anybody else? Hello? Yeah, now look at these two diagrams and see whether I am just going to try out something. Okay? Now what I will do is there is a line B dash A dash. I will draw a line here parallel to B dash A dash. Right? Control and spirit. Okay. So the first one was, I will take it like this. Okay. So the line is like this. So this is AB, right?
No, ulta.
Ulta. Ulta. What is ulta?
Vice versa.
Okay. Let the dabba be there. So one line is like this.
Yes.
Another line is like this.
Yes.
Okay. So this is, you have taken this A dash and B dash. Correct? And this was A and B.
Okay.
Hello, are you all with me?
Yes.
Yes, sir. Yes.
Okay, so what they have done is, this is, sorry, let me try quickly. Okay, so this one they have taken theta 1, this one they have taken theta 2.
Yes.
So what I would think is, I will draw a line parallel to this. That is parallel to A dash B dash. This line that I have drawn here is parallel to A dash B dash.
Yes.
Yes.
Okay, and therefore this angle is again theta 1 and this angle now becomes 90 minus theta. 90 minus theta. Right?
Yes.
So now this line has changed from AB to this line is changed from A dash B dash. Okay, and the angle and this line. Okay, this line is making an angle. So this angle is what? 90 minus theta.
Yes.
Theta 2.
Yes.
Correct?
Yes.
Huh? Hello.
Yes, sir.
Right? So this angle here between this line to this line will be what?
So how we wrote that as 90 minus theta 2, sir? Not.
Yes. Theta 2 is 90.
Theta 2.
No.
Now 90 minus.
Let's wait. Draw it a bit awkward. Okay. Theta 2. Fine?
Yes,
Now
right.
it is 90 minus theta 2. Right? Hello?
Yes, sir.
Then I'll have to change this also. So this line
Yes, sir.
is theta 1 and this line is theta 2. Correct? Hello?
Yes, sir. Yes.
Yes, sir.
So if this line is theta 2 and this is theta 1, so this line must be what? Theta 2
Minus
is theta
theta 2
2,
minus
this
theta.
plus this is equal to theta 2.
Yes, yes, sure.
So this line will be what?
Theta 2 minus theta.
Yes,
Theta
theta 2
minus
minus
theta.
theta 1. Got it? All of you?
Yes, sir.
So therefore,
Yes.
and this has changed in time t2 minus t.
Yes.
So the angular velocity is theta 2 minus theta 1 divided by t2 minus t.
Yes.
Okay?
Yes, sir.
Okay, fine. And now so what will this give me? This will give me omega of b with respect to a.
Yes, sir.
B with respect to a. Got it? Hello?
Yes, sir.
Now the same thing I will do here. See, what I have done here, I have drawn this line parallel to this line. Okay, now I will draw this line, I will draw a line here parallel to this.
Yes, yes.
Okay, I will draw a line parallel to this. right? And this you can prove that this will also be equal to theta 2 minus theta.
Yes.
And what will this represent here? This will represent omega of A with respect to B.
Yes.
So thus it is proved. Hello, are you with me?
Yes, sir. Yes, sir.
I have taken the parallels and I have proved it. Diman, did you get it?
Yes, sir.
Okay. Next, we have to prove omega AB. Omega of the line AB. Omega of the line AB. That is, this itself, see, this line itself has moved here. That is, this itself is moving with omega.
Yes, sir.
And that omega is omega E. So what will you do? You take this line and you take this line, and both of them are going to meet here O, common reference. So with respect to this reference, this line has moved from theta 2 minus theta 1.
Yes, sir. Yes.
Got it? Hello?
Yes, sir.
This
Yes,
line
sir.
is this. So this angle will be theta 2 minus theta 1 in the same way.
Yes,
So this is equal to omega again. Got it? A wide, broad smile on Arun's face, but also a smile from Deepa. Okay, fine. Understood, all of you?
Yes, sir. Yes, sir.
Okay, some geometry, some mathematics, and all that taken as a guidance. Right. Okay, fine. So we have just proved that a line drawn on the object is that means a line drawn on the rigid body which is having both rotational and translator motion. We have seen that it is rotating. So omega B with respect to A, omega A with respect to B, and omega AB are all equal.
Yes, sir.
Be careful, step by step I am teaching you.
Yes, sir.
Don't try to generalize it, because some students are here, they are trying to generalize. Please appreciate and understand. When you take exhaustive examples, many examples, and if you are able to get some generalization out of it, only you should generalize. Otherwise you should not. See, I have first taken a point in the previous case, R1 bar, R2 bar. I have referenced those 2 points with respect to a reference point outside the body. Okay, and we got the omega there, right? And now I have taken a reference line and I have handled this like this. And in this context, we have proved this is equal to this, this is equal to this. Okay, fine. Any questions here?
No, sir. No, sir.
So we proved this, correct? So the same construction is also done here. Same thing. I have explained all these things to you. Now we'll come to the next point. So the angular, say there is abstraction here. Angular velocity omega of a rigid body at an instant is the rate at which one particle of the body rotates with respect to another particle, or the rate at which the line joining any two particles rotate with respect to any fixed reference line arbitrarily chosen.
Yes, sir.
Yes, sir.
So that means between two particles also, and if you join that line to an arbitrary reference line, okay, so there also you can do it. Only thing is, if the particle has translated, then that line that you are joining must also translate. Hello?
Yes, sir.
Yes, sir.
Keep that in mind.
Yes.
That line also should translate if the body is translating. But if the body is only rotating and not translating, okay,
The body.
then you have to keep the reference point there only and draw the diagram.
Reference point is inside the body.
It can be outside also.
Okay. But
Okay,
that
it can be outside also. Okay, see, I took the reference point outside and I did. Here also I took the reference point outside and I did. Okay, see, please don't confuse. You are generalizing. Angular velocity omega of a rigid body at any instant is the rate at which one particle of the body rotates with respect to another particle of the same body.
Yes, yes, yes.
One, or the rate at which the line joining these two particles, right, with respect to a reference line. Okay, the rate at which that line is joining. This example.
Yes, sir.
Okay, see, previous example I have referenced the two particles with respect to this one. I just asked you the relation between all of them. So there also the line joining, that is R21 bar, that was rotated. and we found that as omega into r21 is v2 velocity of 2 with respect to 1. Correct? Now let's understand this problem.